Hello, we are the group 11, and our lesson for today is factors affecting solubility. Have you ever wondered why fishermen fish at night or early in the morning? Most likely when there is no sun at all. It is because fishes are abundant during these times because oxygen is also more abundant at the surface of bodies of water at this specific time. The amount of dissolved oxygen increases as the temperature lowers. That is why fishermen catch fish during early in the morning or night, kay active sa ang mga fishes sa ana mga time. What factors affect solubility? But before that, these are the objectives of this lesson. Explain the effect of temperature on the solubility of a solid and of a gas. Explain the effect of pressure on the solubility of a gas. Describe the equilibrium nature of crystallization and dissolution. Predict the effect of changes in temperature, pressure, volume, concentration, and pH on the solubility of substances in water. Predict the effect of pressure on the solubility of gases using Henry's law. Okay, so let's start. Microscopic view of solution formation. Solution formation, dynamic equilibrium between two opposing processes, dissolution and crystallization. Ini na science kay represent iniyaan ng duha ka process which is dissolution process o crystallization process. When we say dissolution process, it means matunaw or matunaw yaan ng solvent. Ang maglaong sab kita ng crystallization process, it means mahimo yan, makrystallize yan, mahimo yan ng crystal. It talks about a substance na pwede yan matunaw o pwede sabiyaan makrystallize. As you can see here sa next na page, nani nato makita ang process ng dissolution o crystallization. Sa first na glass, dissolution occurs first. Second, crystallization then becomes significant. Then, dynamic equilibrium. This illustration shows the significant stages before dynamic equilibrium. The length of the arrows represent the rate of dissolution. Hidtong pink. Tapos ang crystallization kay black. Para mas masabtan, maghatag ako ng example. For example, ari ka ng glass of water. Tapos butangan ko ng powdered juice. 'Di ba ang powdered juice kay ma-dissolve yaan, amo yan ang dissolution process. Tapos dayon, sa ikaduha na glass kay kibali halot dako ang powdered juice sa kanak solvent na water. Tapos dayon, pag ibutang ko ini sa ref, kasayad ka o na mahimo. Kay kasayad sa kita na ang temperature ng ref kay mag-decrease. So mahimo yan ng bugnaw. Tapos masolid dayaan, amo yan ang process ng crystallization ng isa ka liquid mahimo ng solid. Og makita sab nato nga ni sa first glass na ang substance kay ang araw naan kay pataas, so it means malusaw gadyan or matunaw. Tapos sab sa ikaduha na glass kay crystallization nga na kay ang araw kay yung pasuod, so it means mag nang gabuo ng solid na substance. Tapos amo din ang dynamic equilibrium. Sa dynamic equilibrium kay constant dayan or yung balance dayan. Na ari kuan na yang tunaw ug ari sa biyahimo na crystal. I hope you understand ang mga factors affecting solubility, nature of solute and solvent, temperature, pressure or volume, mechanical changes. Matakil ta ini doon sa sunod ng mga reporters na mag-discuss. The first factor that affects solubility will be discussed by Mr. Rafael Manlangit.
Factors affecting solubility. Solute to solvent interaction. The nature of solute and solvent. So, ang solute is yan ang tunawon. Example is yan ang tunawon sa isa ka water. Then, ang solvent yan ang magtunaw. Like dissolve like. Ang pasabot sini is if ang duha ka kuan is same ng chemical properties, ma-dissolve siran. Example is ang tubig ug ang asin. Solute and solvent molecules with the same intermolecular forces are soluble to one another. Stronger interaction between solute and solvent molecules with similar intermolecular forces is more soluble. So, ang stronger interaction between solute and solvent is more soluble siran. Ionic solid are more soluble in a polar solvent than non-polar solvents. So, ang ionic solid are more soluble yan sa polar solvent than sa non-polar solvent. Then, ion-dipole interaction are stronger than ion-induced dipole interaction. So, ngani, ang ion dipole kay mas stronger yan compare sa induced dipole interaction. Polar molecules are soluble in polar solvent. So, ang polar molecules kay mas soluble yan sa polar solvents in dipole-dipole interaction. Non-polar molecules are soluble in non-polar solvents sa London dispersion. So, ang non-polar molecules kay mas soluble yan sa non-polar solvent. Compound with each bond are soluble in polar solvent. So, hydrogen bond between two ethanol molecules. So, ining red dot na makita nato sa picture is yan, amoy ng hydrogen bond between sa duha ka ethanol molecules. Then sa other side is hydrogen bond between an ethanol molecules and a water molecules. Same gyapon nga ni ang red dot is represent as hydrogen bond between sa ethanol o sa water molecule. Solubility. The solubility depends on the amount of solute and solvent present in a solution. So ang solubility, yan ang process ng solute o solvent. Example sini is amoy tong asin o ang tubig. Pag ang asin is represent as a solute, then ang water is represent as solvent. Pag matunay itong asin sa sulod ng solvent, amoy nang gitawag nato na solubility, which is mag-dissolve ang kuan isa ka chemical sa water. Dissolution of ionic solid in solubilities of some alcohol in water and hexane in mole ROH per 100 G solvent at 20 degrees Celsius. So there are 6 alcohol. First is methanol, ethanol, propanol, butanol, pentanol, and the last one is hexanol. First is methanol. The methanol alcohol is, ang kanang solubility is infinity, din ang hexane is 0.12. Din ang sa ethanol is both infinity sa water and hexane. Sa propanol is infinity, both infinity gihapon sa water and hexane. Ang butanol is 0.11 ang sa water solubility, while sa hexane is infinity. Then sa pentanol is 0.030 ang sa water solubility naan. Then ang sa kanan hexane is infinity. Then sa hexanol is 0.058 ang kanaan water solubility, while ang kanaan solubility sa hexane is infinity. Suppose you want a drug that is soluble in water. How will you increase its solubility in water if you can change its chemical structure? So example sini if ang kuan uno na to pagkuan sa water para ma-change ang chemical structure. Ang kanato lang mo niya na is adan ta ng temperature. Example sini is mag-kuan kita, mag-init kita ng water para ang isa ka chemical na kuan is mag-change ang kanang chemical structure. Temperature, the most evident factor that affects the solubility. So ang temperature yan gid ang kuan lang pa effective na makakuan sa solubility, na which is mas dali makadissolve ang kuan solvent pag mas taas ang temperature. Most solid are soluble at higher temperature. So lang same sitong lang ko gaina pag gahi ang most solid, mas soluble yan if higher ang kanan temperature. Solubilities of ionic compounds as function of temperature. Amay na makita nato nga nasa graph. The steeper the slope of the curve is equal, the greater the effect of the temperature on the solubility. So, sa makita ta sa left side is amoy na ang solubility ng salt 100% to sa water. Then yan si sa baba, which is represent sa temperature naan, amoy na ang start niya po niyan sa 0 to 100% na degree Celsius.
Temperature. Solubility of gases decreases as temperature increases. So in general, ang solubility of gases in liquid decreases as the temperature increases. This is because as temperature rises, ang kinetic energy ng gas molecules mag-increase isa, causing them to move more rapidly and escape from the liquid phase more easily. For example, imagine you have a glass of soda. Kung warm yaan, ang bubbles of gas na amon sa soda is mutakas si andali. Pero kung tignaw itong soda, is magstay ang gas into the liquid. So colder temperatures generally make gases dissolve better in liquids. Always remember, the solubility of most solids increases with temperature. The solubility of gases decreases with temperature. Kung mag-init kita ng liquid like tubig, makadissolve gayaan ng more solid stuff like asukar or asin. Nang ginatawag na solubility of most solids increase with temperature. Pero sa gases, like ito sa bubbles in soda, kung mag-warm up kita ng liquid, it can't hold onto the gas as well, so the bubbles escape more easily. The solubility of gases decreases with temperature. Pressure or volume does not significantly affect the solubility of solids and liquids. Pressure or volume don't usually have a big impact on how much solids or liquids can dissolve in a solvent. Kay tungod, ang solids or liquids is more on temperature. Greatly affects the solubility of gases. By increasing the pressure, increases the amount of dissolved gas in solution. Kung ang solid and liquid is more on temperature, ang gases is for pressure and volume. Makahiming sir ng body difference in how much of them can dissolve in a liquid. The effect of pressure and solubility of gases. In the first picture, makita ta ang isa ka container na aray cover. So yung cover is amoy na naghahatag ng pressure within that container. Kung makita ta na ang cover is wala kadayo ma-press pasingod sa water. Amoy na resulta na ang gas na aron sa container is wala kadayo yalubog sa tubig. Kay tungod, badi pa na space ang aron sa container na makakuan ang isa ka gases. Unlike nga ni sa second picture, makita tagayod na ang
gases isi-dissolve gayud diyan sa tubig kay tungod sa pressure naghihatag ng cover sa container. Ug iyang cover is amoy iyan ang trap sa gases para mas muduolian sa tubig or ma-dissolve. Henry's law, the relationship between pressure of the gas over the solution and solubility of the gas.
So this is the formula of Henry's law, which is C gas is equal to pH times P, where the C gas serves as the concentration of gas in the M or molar solubility. P stands for pressure of gas, ppm or atmosphere. pH is the Henry constant in specific gas solvent.
So Ms. Guarin already introduced the formula. Now we're going to try to solve this given. Calculate for the molar solubility of carbon dioxide inside a bottle of cola if its partial pressure is 3 atmosphere at 20 degrees Celsius. The Henry's constant for carbon dioxide dissolved in water at 20 degrees Celsius is 3.3 times 10 to the power of negative 2 meter per atmosphere. To calculate the molar solubility of carbon dioxide in water at 20 degrees Celsius with a partial pressure of 3 atmosphere, we can use Henry's law. So bago na makuha ang result, dapat imutang tagid na ang formula, which is C gas, nagapasabot yaan ng concentration of gas, amay ni ang molar solubility. Tapos ang KH, kay ga-represent yaan ng Henry's constant at a specific gas solvent. Tapos ang P, it means pressure of gas. Kaya kuha na sa nato ang formula, i-substitute din nato ang given. Sa KH, ang Henry's constant kay kuan, nga niya kabutang 3.3 times 10 to the power of negative 2 meter per atmosphere. I-times mo lang yan sa pressure of gas. Yung atmosphere. I-times mo lang yan sa atmosphere. 3.3 times 10 to the power of negative 2 and per atmosphere times 3. Yakuha sa nato ang answer na 0.099. Kanato yun scientific notation. Ang answer kay 9.9 times 10 to the power of negative 2 molar. Kay, ang gihanap sa kay molar solubility. So, ang unit nato kay M.
What is the molar solubility of HT in a diverse tank if it exerts a pressure of 2 atm at 10 degrees Celsius? The Henry's constant for CO2 dissolved in water at 10 degrees Celsius is 3.7 times 10 to the power of negative 4 molar solubility over atm or atmosphere. So let's find out.
So let's try an example. So ang gihanap natin is ang gas. So gi-cancel taon ito para mabilin ang molar solubility. Di-times na lang yung 3.7 times 10 to the power of negative 4 to 2. So ang answer is 7.4 molar solubility.
Here's another example. Calculate for the pressure exerted by CO2 in a cola bottle if its molar solubility in the solution is 1.1 times 10 to the power of negative 2m at 20 degrees Celsius. The Henry's constant for CO2 dissolved in water at 20 degrees Celsius is 3.3 times 10 to the power of negative 2m over atm.
So may yung isa ka formula ng Henry's law, which is ang pressure ang gihanap na isa. So mag-example kita. So, mag-solve ba kita? So, para mabili ng ATM, cancel ka ang molar solubility. Then, substitute pa iniyaan ito division. Answer is 0.33 or 3.3.
Calculate for the pressure exerted by O2 in a diverse tank if it has a molar solubility of 1.0 times 10 raised to negative 2 m at 25 degrees Celsius. The Henry's constant for 0 to dissolve in water at 25 degrees Celsius is 1.3 times 10 raised to negative 3 m per atmosphere. C gas KHP, where C gas stands for concentration of gas or M and P stands for pressure of gas or atmosphere, KH or Henry constant at a specific gas solvent. So here are the formula. P is equal to C gas over KH. P is equal to, then substitute natin ang value ng C gas, which is 1.0 times 10 raised to negative 2 m. Then ang sa KH or Henry's constant is 1.3 times 10 raised to negative 3 m per atmosphere. Cancel ang 2 ka m since it is same. Then i-divide ang C gas og ang Henry's constant, which result 7.692. Since round up ang 9, so 7.7 atmosphere. So the O2 in the diver's tank exerted a partial pressure of 7.7 atmosphere.
Mechanical changes. Steering. Improves the solution. Adds heat to the solution. Increases the probability of contact between solid particles and solvent particles. So, syempre, kung mag-steer kita or magkutaw ng isa ka solid sa tubig, kay mas dali yaan ma-dissolve kito mag-gi-kutom sa. O kung maggamit kita isab ng kuan ng heat or init, kay mas napadali ang pagtunaw ng isa ka solid sa liquid. Like sa kung magkape kita, diba? Maggamit kita ng hot water. So, itong gibutang nato na sulyot is dali dagigyan matunaw sa solvent. Increase in surface area. Improves dissolution. And granules are more soluble than blocks.
When we say granules, amoy ng mga tiny particles or powder yaan. So, mas dali yaan mo matunaw kaysa sa blocks. Increase in surface area meaning para ma-enhance ang chemical reaction. Amoy yan na ang granules is more soluble kaysa sa block katungod ang granules is mo spread out yaan dali sa liquid kaysa sa blocks na mag-stay put lang yaan.
And that's all. We hope you understand. Thank you.